Hi friends, in this short video we'll take a look at single sign-on, the possible approaches and a brief overview of them. So let's get started. What is single sign-on? So usually an organization would contain multiple users and users would be accessing multiple applications, right? Expecting user to have a different set of credentials for all the applications and remembering them would be a nightmare. Now let's say a user keeps the same username password across the application, then that is also a compromise on the overall security. So what single sign-on provides is it allows users to access applications without being required to enter credentials every time. So you log in into a parent application or a parent system, and whatever you access from there will allow you to access the target applications without asking you to provide the credentials again. For single sign-on, HTTP stateless nature is one of the major considerations, due to which client server session handling is playing a critical role. So most of the folks know, right, that there's something called as HTTP session, which allows a client server to do a handshake, and the server can identify that the client or the browser connecting to the server is actually the same client which has been authenticated earlier, right? So that is one aspect to it, and the third aspect to it is the overall token security. The token which is being used to extend the session, right, or authentication to other target applications should be secure enough so that nobody can easily impersonate the actual user who has logged in. Coming to the possible approaches, there are three possible approaches. At a high level, we could have a agent based SSO, pluggable authentication module inside the application server. JAS is a well known PAM based solution. And the third one is federated identity design pattern, where the identity provider is being leveraged by the service provider or the target applications to get the logged in user's identity. So what is agent based SSO? Ideally, agent based SSO will have a pluggable module embedded in your web server. It would be installed on the web server to intercept your incoming request. It will then connect to the other SSO landscape components like the policy server or the SSO config server to leverage the corresponding configured rules and policies to evaluate whether the incoming request should be routed to the authentication page, whether it should allow the user to access the actual application, whether you need to extend the session based on what configuration and so on. And in this particular case, usually the coarse grain authorization is handled by agent based SSO, and the fine grain authorization is done via the application itself. Let's take a look at a very high level landscape. For agent based SSO, user will make a request. The request will ideally go via the standard internet request, landing on the intermediate components and finally entering the corporate network in your or landing on your web server. From the web server, the agent will intercept it. Agent will then connect SSO servers, read the config, store, run the given set of policies and rules, and then it will most probably forward the request to application server. The war or the ER whatever is deployed on the application server will run the standard business functionality leveraging the application DB. And when the response is being sent back again via the web server, the agent would then most probably update the SSO cookie or token, which will be then uh, passed on by the browser in the subsequent request. Coming to JAS. Now JAS is a standard way of allowing you to plug in authentication and authorization independent of the application logic. So authorization will ensure that the user has the required set of access control rights or permissions. The critical components of JAS are subject. It represents a user information for a single entity. Subject would then basically contain relationship to other things such as principal. Principal is used to indicate a single object. or a single rule. A particular subject can have multiple principals. For instance, a subject or a user might be identified by his unique username. He might also be identified by a social security number and so on. Subject can be associated with one or more principals. A subject may also own other security related attributes which are might be a private set of attributes, as I said, social security number, and might be a public credential set which would contain a public set of attributes like first name, not first name, might be email or stuff like that. JAS is used for authentication authorization, and other critical aspect is the login context, which describes the authentication methods being used to authenticate the subject. So with JAS, the entire authentication is handled at the container level by the server, and then it the JAS plugin will then inject this subject and the other principal related information into the login context, which is then leveraged by the application to further decide on the functionality and take the user to the appropriate page. Federated identity is user is basically leveraging a single authentication ticket or token across multiple IT systems. So as I said earlier, right, we have a identity provider, which is the source system, which will ideally connect to Active Directory or a user store which contains the user information. And federated identity is based on the concept of trust between multiple domains or multiple systems. So federated identity is also leveraged across multiple organizations. You would have seen doing a federated identity between Google and your mobile app, right? So when you say sign in via Google, so you're doing actually a federated identity over there. So Google is leveraging your logged in user details and providing in the required user attributes to the mobile app that you are signing up on. So federated identity, there are two well-known approaches. One is the SAML, which is SAML stands for Security Assertion Markup Language. It is a extension of XML, and it is designed explicitly to pass on the security information between two systems over the HTTP protocol. HTTPS protocol is what is preferred. And SAML requires a trust setup, so you need to share the metadata between the identity system and the consuming service provider or the target system, and that requires sharing some information like the public key of the certificate and so on. And once the setup is done successfully, when you make a request to the target system, it will redirect you to the identity provider, where identity provider will then authenticate you, and then it will pass on the required user detail to the target system, back to the target system on a session URL. On the session URL, the target system will read the SAML payload, and it will then extract the user attributes, and then it will decide on the user role and take you inside the application. Similar flow is there for OAuth, but OAuth is based on a different concept. At a flow level, it is a bit similar. We have OAuth where we leverage OAuth for authorization. When you try to access a particular system, let's say the target application, it will try to take you to the OAuth identity system or the resource server, where it will leverage the concept of access token and refresh token, and then based on that it will extend the corresponding session, and it will allow the provide a new token for you to be taken inside the target application. SAML and OAuth are itself very used topics. I'll most probably make separate videos on that. And this is all I had for you guys as a high level setup. And stay tuned for the new set of videos coming up on SAML and OAuth. Thanks a lot. Thank you.